We are starting a unit on probability, and the first day or two of probability, we actually aren't going to do any probability. Because first we have to figure out how to count things. So we are going to look at the fundamental counting principle, permutations, combinations, all different ways that we count how things happen. For example, if you have 2 pairs of pants, let's say they're black and blue, and 3 shirts, solid, striped, and plaid, and for those of you who care, let's say that they all coordinate with each other no matter which you choose, how many different outfits can you make? So there's multiple ways to do this. We could write out black pants, solid shirt, black pants, striped shirt, black pants, plaid shirt, but I'm going to write down black for my pants and blue for my other pair of pants. If I choose my black pants, I can then choose to wear either a solid shirt, my striped shirt, or my plaid shirt. If I choose the blue pants, I can then choose the solid shirt, the striped shirt, or the plaid shirt. This is called a tree diagram, and the end of each branch, like this top branch, is black pants, solid shirt. That's one outfit. So the ends of this represent the total number of outfits. There are 1, 2, 3, 4, 5, 6. There are 6 outfits. A student just brought up a really good point. They very, very frequently have questions like this on the ACT. This is how you do this. Now, it takes a long time to draw this tree diagram out. Is there a shortcut? Think about there were 2 pairs of pants and 3 shirts. How can you use the number 2 and 3 to get 6? 2 times 3. So, flipping 2 coins. What can you get if you flip a coin? Heads or tails. There's 2 options. So there's 2 options for the first coin. There's 2 options for the second coin. There should be 4 total options if we flip 2 coins. First we have heads, 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 tails. We also have tails, heads, tails, tails. There are the 4 options for flipping 2 coins. Both of these examples illustrate the fundamental counting principle. If one event can happen M ways, say putting on black or blue pants, and another event can happen N ways, say putting on a solid shirt, a striped shirt, or a plaid shirt, the total ways that both events can happen is M times N. So you multiply the number of things together to get the total number of outcomes. Here's a restaurant example. And I like to go through and actually write the numbers in. So there are 3 potential appetizers, there are 4 potential drinks, there are 3 entrees, and there are 5 desserts. I like this restaurant. 5 dessert options, that's money. And they have Dr. Pepper on the drink menu. I'm set. Totally set. How many ways can you order an appetizer and a drink? How many appetizers are there? 3. How many drinks are there? 4. 3 times 4 is 12. I would like you to try B and C on your own. You should get 20 and 180 for those 2 options. We also can do slightly more complex things. The standard configuration for a New York license plate is 3 digits followed by 3 letters. I'm going to visualize this. These 3 are going to be digits, and these 3 are going to be letters. Okay, the digits are 0 through 9, which means that there are 10 digits. So there's 1 through 9 and 0, 10 digits total. So for the first digit on the license plate, how many digits are there that we could use? There's 10. For the second digit on the license plate, how many digits are there that we could use? 10, 10. Next, we look at the letters. How many letters are in the English alphabet? 26. So there are 26, 26, 26. You would multiply all of these together to get the total number of possible license plates. This is if the digits and the letters can be repeated. After this, we're going to talk about what happens if they can't be repeated. So if we plug this into our calculator, If you get scared because it's a huge number, that's okay. It should be a huge number. 17,576,000. Now we're going to do this again, but this time the letters and digits cannot be repeated. So just a reminder, these first three are going to be digits and the second three are going to be letters. Imagine that I put the numbers 0 through 9 on cards. Each card has one digit on it. And I shuffle them up in my hand. And then I ask you to draw a card out of my hand. There's 10 cards for you to choose from. So there's 10 possibilities for that first digit. But then we're going to pick one of those numbers and set that down on the table. How many cards do I have left in my hand to choose from for the second blank? Now there's only 9 possible digits because we've used one of them. And then for the third digit, we've used 2 of the digits, so now there's only 8 digits left to choose from. So when we say cannot be repeated, we are going to have to subtract 1 from each successive blank to show that we have selected one of those digits and used it, and now there are fewer choices to choose from. For the letters, we start with 26 options. What are the next 2 blanks going to look like? 25 and then 24. Plug that into your calculator and see how that number compares. States actually have to do this because if they know how many motor vehicles approximately they need to have licensed, they need to make sure that they have enough license plates to meet that need. So they have to figure out how many digits do we want to use, how many letters do we want to use, do we want to repeat digits or letters. You could even do something like digits can't be repeated, but the letters can be repeated. But then you also have to think about taking out certain options. Like I'm sure there are some 3-letter words that maybe you wouldn't want to just randomly put on a license plate. I'll let you high school hormone raging brains just think about that for a second. Okay, and moving on. How many ways can you arrange the letters of the word chiefs without repeating any letters? So we do the same thing. There are 6 letters in the word chiefs. If I put a C on one card, an H on another card, and then an I, and so on, shuffle them up in my hand, there are 6 possible letters to choose from for that first letter. We pull one of them out. There's only 5 left. And then 4, 3, 2, 1. Plug that into your calculator quick. 720. Now, that wasn't so bad plugging it into your calculator, but what if I gave you a 12-letter word? Wouldn't it take a while to plug that all into your calculator? This is the same as an operation called factorial. 6 times 5 times 4 times 3 times 2 times 1 is the same as 6 factorial. We use an exclamation point for factorial. Now, this does not say 6! It says 6 factorial. So an exclamation point in math does not mean excitement. I mean, it does because factorials are exciting, but it means factorial. And the really important thing about factorial is that there's a button in your calculator that does this. I'm going to take this Alpha Windows 7 thing out because that is not accurate. In a scientific calculator, you would push the number first, so push a 6 into your calculator. And then, you know your PRB button that you've always used to transfer fractions to decimals, but you've never actually used the PRB button? If you push PRB, you have 3 options: NPR, NCR, and exclamation point. That exclamation point is the factorial. So punch in 6 factorial into your calculator and see that it also gives you 720. And then I want you to try doing 9 factorial and 12 factorial to see what you get. You should get 362,880 for 9 factorial, and for 12 factorial, 479,001,600. Say I asked you to take the word, I don't know, Gilmore. There's 7 letters in that word. If I wanted to, how many ways can you arrange the letters of the word Gilmore? you would do 7 factorial, and that would tell you how many ways you can arrange those letters. This leads us to permutations. A permutation is an arrangement of objects in which order is important. For example, GIL is different than LIG is different than ILG. So if the order of the letters matters, it's a permutation. Another example is I'm going to look at this classroom and pick 3 students and give one of them first place, another one second place, another third place. So using totally random student names, because I'm recording so I'm not supposed to use actual student names, if I had Sam be first place and Mary be second place and John be third place, talk about total like random lame names. Sorry if anybody you know has those names. One of them's my daughter's name. But that would be different than Mary getting first place, Sam getting second place, and I don't even know what name I said for the third one. So the arrangement of those places matters. Keywords to look for are, if you see the word order or arrange, it's going to be a permutation. So the long way to do this, how many ways can you arrange 3 of the letters in the word Chiefs? Now you can do this using blanks. There's 6 letters in the word Chiefs, and then 5, and then 4. But what if you had 26 items and you wanted to arrange 20 of them? That would be a lot of work. Wouldn't it be nice if there was a button in our calculator that did this for us? There is. It's called NPR. NPR is more than just a radio station. It is called a permutation. NPR means that there are N objects. We're going to arrange R of them. So in this case, there are 6 letters in the word Chiefs. We are going to arrange 3 of them. There is a formula that you can follow, but honestly, there's a button in your calculator. We're just going to use the button in our calculator. I just need you to know when to use NPR and when to use NCR. We're going to cover NCR tomorrow. So in example 8, 5P3 means that you have 5 things. You're arranging 3 of them. So the first number is the total. The second number is how many of them you are arranging. So I've got 5 students, and I'm going to pick first place, second place, third place out of those 5 students. In your calculator, you would punch in the 5, then go to your PRB button, and one of those options is NPR. So you'd see this NPR on your screen, and then you would click your second number, which is 3. So 5 NPR 3, and you should get 60. If you're using a graphing calculator, all of these features are in the Math button, and then arrow over to the Probability menu. You'll see NPR in there. You'll see the exclamation point. All of that stuff is in there. 8P3 means we have 8 objects. We're arranging 3 of them. So try 8P3 in your calculator and see what you get. Then try 9P1 and see what you get. So let's say that you have a collection of 25 figurines. I'll let you decide if that's unicorns, dinosaurs, action figures, whatever type of figurines floats your boat. You have room on your shelf to arrange 15 of them. Now, obviously, rainbow unicorn followed by blue unicorn would be different than blue unicorn followed by rainbow unicorn. So how many ways could we arrange 15 figurines? Keyword here is arrange. That word arrange tells you that we are going to use NPR. So what number do you think would go first? 25 and then P15. So try 25P15 in your calculator. Oh, I should have used less numbers. That is 4.27 times 10 to the 18th. There's a whole bunch of ways that you could arrange those figurines on your shelf. So get to arranging, because that's a lot. Yes, you always put the big number first. In NPR, N is the total number of things, and R is how many you are arranging.